Hi everyone, this is the video for chapter 4.1, 4.2, graphing linear equations and functions. Specifically, we're looking at how to graph them using a table of values or a table of ordered pairs. And really the second objective of this presentation is, and I should have written it down, is to check whether or not an ordered pair is a solution to a linear function. Okay, so let's take a look at what I mean by that. Let's start with vocabulary. Linear equation. How do we know if an equation is linear or not? Well, in general, a linear equation has two variables, an x and y, although sometimes, as we've seen in the past, there could be other variables. And there are a couple of exceptions, and I'll get into that in a minute. But in general, the linear nature will happen or occur when the equation has an exponent of 1. Okay, so here we could have x and y, so two variables in the equation, but both of them have an exponent of 1. Now there is an exception. So by the way, here we've got y equals 2x plus 5. That's certainly linear. Here, this one is not. And the reason why that's not a linear equation is because that y has a square on it. Also here, y equals 2x squared plus 5. That has an exponent of 2, so that's not going to be the case. Now there are a couple of weird ones here. X equals 5, y equals 5. Neither one of those have two variables. They each have 1, but that's okay. They're still linear because there are no exponents on the variable. So all four of these circled here are going to form lines on the xy coordinate plane. All right, let's take a look over here. What is a solution to a linear function? A solution to a linear function is going to be an ordered pair. And we know that this first number, for instance, is the x, and the second number is the y. And we're trying to see, without a graph, whether or not this ordered pair is a solution to this linear function above, y equals 2x plus 5. Well, we could always graph it. I mean, if we wanted to graph that, this point or that point would be a solution if it's graphed right on top of that line. If it's graphed somewhere else on the coordinate plane that's not on the line, then it would not be a solution. So you could certainly do this visually. But we can also do it more analytically by substituting. So I'm going to start here. I'm going to say y equals 2x plus 5. And now I'm going to substitute. I'm going to substitute y equals 7, because that's what I have up here in my ordered pair that I'm checking out. And I'm going to substitute x equals 1. And I'm going to see what happens here. Now, I'm going to say 7 equals 7. 2 times 1 is 2, plus 5. And 7 equals 7. And I have equality. By the way, that noise right there is my dog Kane crying because somebody just came home. And he loves when people come home. So that's why he's crying. So if I get true equality here, 7 equals 7, I know that the point 1, comma 7, that point, location, is going to be right on top of that line graph. And it is a solution. Now let's take a look at this point here, located at 1, 10, 1 comma 10. So let's try the same thing. We're going to go back to the linear function and substitute in. Okay, so we've got 10 in here for y and 1 in here for x. I'm substituting those in and we're going to see what we get. So we've got 10 equals 2 times 1 is 2 plus 5, and here we have 10 equal to 7, which of course 10 does not equal 7. So right here we can see that 110 is not a solution. So you've got two ways to figure this out. You can look visually on a graph or substitute. Okay, let's take a look here. we've got two different linear functions here as an example. We've got y equals negative x plus 4 and y equals negative 1/2 x plus 1. And out of all 6 ordered pairs here in each of these boxes, I'd like to see if you can determine which ordered pairs are a solution and which are not. And there is no substitute to that other than graphing the line or substituting. So let's try the substitution method. I'm going to work up here. Y equals negative x plus 4. And I'm going to start with this very first ordered pair. 2 equals negative 0 plus 4. We could see 2 does not equal 4, so we can eliminate that. Starting again, let's try this 0, 4. So now we're going to put in 4 for y equals negative 0 plus 4. 4 does equal 4. That's true. So we've got one solution so far. And by the way, how many solutions are on a line? Well, actually, a line goes infinitely in both directions. So there's an infinite solution set. So we're really just testing out a few here. All right, let's do it again. Now I'm going to try 1, 3. Whoops, I did not mean to circle that. I meant to highlight. Okay, so let's try 1, 3. And we've got 3 in for y, negative x, so that would be negative 1 plus 4. 3, does 3 equal negative 1 plus 4? And it certainly does. So we've got a second solution. And let's try again. 5 in for y. And now be careful here. We've got a negative x and a negative value for x. So be very careful. We're going to put a negative for the negative x, and then our value is negative. So hopefully you can see that we need to be very careful with that. So we have 5. Well, this is saying the opposite of negative 1 is positive 1. So that turns positive. And 5 certainly does equal 5. So we got a third. Now let's start with 8 in for y. And again, a negative x, and x value is negative 4. So we've got to be really careful with the sign there. Plus 4. So does 8 equal, this is negative, negative, positive. 4 plus 4, 8 does equal 8. So we got another one. And finally, 8 goes in there for y, and we've got a negative, negative 2 plus 4. That's 8 equals 2 plus 4. And of course 8 does not equal 6, so that is not a solution. Okay, let's look at this example over here to the right. We have y equals negative 1/2 x plus 1. Let's take our very first ordered pair, 2, 2, so we're going to substitute in 2 for y and 2 for x. See what we get here. So 2 equals, well, negative 1/2 of 2, we can put that over 1. We end up here with, multiply the numerators together with negative 2, multiply the denominators together, and we have 2 equals negative 1 plus 1. 2 equals, well, opposites, negative 1 plus 1 is 0. So we know 2 does not equal 0. That is not a solution. Let's try another one. We're going to try this ordered pair here, 2, 0. So we put in 0 for y, negative 1/2 times 2 for x, plus 1. Remember, first one is x, second number is y. All right, 0. Does that equal 1/2? Well, let's try that again. We've got negative 1 times positive 2 is negative 2. 2 times 1 is 2, plus 1. And we have 0 equals negative 2 divided by positive 2 is negative 1, plus 1. 0 equals 0. So that is certainly a solution. In the interest of time, I'm going to ask that you continue with these. You might need some scrap paper to slowly substitute each value. All right, now let's see how we graph a line from a function just by creating a table. First step is to create a column of inputs and outputs, and we may even want to expand our table a little bit to solve for y. or calculate what y is. We're going to choose some values for x. We're going to substitute those values in for x and then calculate the subsequent value for y, or the corresponding values for y. And then we're going to graph each ordered pair and draw a line through those. Okay, so let's take a look here. I think I am going to move this up here, maybe over here, and make our table a little bit bigger. All right, so we have a function here, y equals 3x minus 2. Let's choose some convenient values for x. Let's choose a negative. Let's try a -1, a 0, a 1, 2, and a 3. Those are some good values. All right, so in the interest of space here, I'm going to say x value here, and then I'm going to say y equals 3x minus 2. So I'm going to calculate what that equals, and then I'll come up with our value of y. So x, -1, substitute. 3 times a -1 minus 2. Well, 3 times a -1 is -3. -3 minus 2 is -5. So we have one ordered pair so far, -1, -5. Let's try 0. 0 is always a good one because it makes the math really easy. 3, we're going to substitute in right here for x, our 0. So that goes in there, minus 2. Well, 3 times 0 is 0, minus 2 is -2. So we have another ordered pair here, 0, -2. Remember, always, this is x and this is the y. All right, let's try 1. 3 times 1 minus 2. Well, 3 times 1 is 3, minus 2 is 1, positive 1. So we've got another ordered pair, 1, 1. And finally, we're going to try 2. 3 times 2 minus 2. Well, 3 times 2 is 6. 6 minus 2 is 4. So we've got another ordered pair, 2, 4. And finally, we'll do 3. 3 times 3 minus 2. We've got 3 times 3 is 9. And 9 minus 2 is 7. So our last ordered pair is 3, 7. So let's take a look. We've got -1, go to the left 1, and down 5, -5. Make a point right there. And where is that point? The point is actually right there. Sorry that my graph is so small. We've got 0, -2. So 0 in the x direction means we don't go right or left. So we're just going to go down our -2 here. And we've got 1, 1. So that's to the right 1 and up 1. And we've got 2, 4, 2 up to 4. And we've got 3, 7 all the way up. So we've got 7 here. And I'm going to sketch, so my line's probably not going to look great, but ideally we would have a ruler and make a nice straight line. So this line that we just graphed is the function, the linear function, y equals 3x minus 2. And let's try another one here. We've got 2y minus 4x equals 8. So I'm going to move up a little bit, make some room here. Okay, so let's try some different values. Let's go with -1, 0, 1. In the interest of time, we'll just stop at 2. So we've got 2y minus 4x equals 8. Let's make our life a little bit easier and solve this for y, because that's ultimately what we want to do. We want to substitute in a value for x and solve for y. So if we want to get y all by itself, we have a bunch of stuff around y. Sorry about my dog Sammy is barking. So what do we have around y? We have a multiplication of 2. That's multiplication at this level in PEMDAS. And we also have subtraction of 4x. So let's mark that level here. That's at this level. We want to undo those operations from the bottom up. So that means we're going to add the 4x to both sides and get that out of there. So 2y comes down. Opposites. Notice I didn't, by the way, add 4. I added 4x because that's the entire term here. Opposites reduce to 0. Now, these two, 8 and 4x, are not like terms. So the only thing I could do is just bring them down, 4x plus 8. And they cannot be combined any further because they're not like terms. Now we've taken care of that subtraction inverse operation. Now let's take care of the multiplication. So we undo multiplication with division. When I divide this 2y by 2 to get the 2 away from y, I've got to divide the whole enchilada over here. So we've got y equals, well, 4x divided by 2 is just 2x, and 8 divided by 2 is 4. So our linear function, this is what we would call an equivalent linear equation to this. They are equivalent. Let's even mark that. They are the same. If we were to graph those two right on the same xy coordinate plane, those lines would be right on top of each other. They are equivalent, we would say. All right, so let's make a little table here. X, I'm going to say, is -1, 0, 1, and 2. And I'm just going to make my function over here. So we know that y equals 2x plus 4. All right, so this is y equals 2x plus 4. And we're going to end up getting our y out of here. All right, substitute. So 2, get rid of the x and put in -1 plus 4. So 2 times -1 is -2. -2 plus 4 is +2. So we've got one ordered pair, -1, +2. Now let's put in 0 for x. 2 times 0 is 0 plus 4 is 4. So we have 0, 4 is another ordered pair. And let's put in, let's put in our x equal 1. 2 times 1 is 2, plus 4 is 6. So we have another ordered pair, 1, 6. And finally, I'm going to substitute in x equals 2. And I have 2 times 2 is 4. 4 plus 4 is 8. So our final ordered pair is 2, 8. And let's graph. -1, we're going to go to the left one, and we're going to go up 2. For +2, right there. And 0, 4, that means we're going through the y-axis. That's called the y-intercept right there, if you recall. And that's going through the y-axis at 4. And we have 1, 6, 5, 6. And we have 2, 8. So that's 6, 7, 8. That'd be right at the top there. And we can go right through those points. Notice I'm not drawing a segment. I'm not drawing a line from this point up to that point and ending. That would be called a line segment. This is a line, and the definition of a line is going off infinitely in both directions. So this function here, we could say is 2y minus 4x equals 8. Or we could just as easily call it y equals 2x plus 4 because they are equivalent. And that concludes our video here today. Thanks for listening, and subscribe to my channel. Thanks.